Hi, everyone. Really glad to have you guys join us for the inaugural version of MongoDB World.live. My name is Res Khan. I'm a senior product manager at MongoDB, and today I'm excited to bring to you one of our newest features that we released a few weeks back called Schema Suggestions in Atlas. Before we dive a little bit more deeper into what the tool is and the presentation, I again want to thank you all for taking some of your valuable time and joining us today. I completely understand that it's a very stressful situation for most of us, and I sincerely hope that you and your family are doing safe and staying sane during these times. And I do hope that the next 20-30 minutes gives you a little bit of distraction from COVID, which I'm sure all of us are yearning for the day that it comes. So before we start going into more depths, want to just give you a quick introduction to myself. I am a product manager, like I mentioned. I live in New York and work from the New York office. And I look after the team that we internally called Insights and Telemetry. And what my team does is we collect performance analytics across hundreds of thousands of MongoDB instances around the world, both in Atlas, Cloud Manager, Ops Manager, and then surface those insights back to our users either via charts, APIs, logs, and other tooling, so that they can go and diagnose performance issues and optimize the way they're using MongoDB as quickly as possible. So if you had used any of our management products such as Atlas or Ops Manager or Cloud Manager, my team builds tools such as Performance Advisor or Profiler, for example. So before we dive a little bit deeper into it, I want to talk through what we're going to cover today. I want to keep in mind that this is not a deeply technical talk. This is more a product level announcement where I'm going to talk about the reasons why we build schema suggestions, how it works, do a quick demo, and talk through what's next. Since data modeling and schema design is a very popular topic, we have a number of talks today in .live about how to design data models and how to design schemas from a bunch of my really smart colleagues. I'm going to talk about what those talks are at the end of the deck as well, if you're interested. So let's dive in without further ado. So why did we build this? Ironically, the reason why we built this is one of the reasons why people love MongoDB so much. We like to think of MongoDB giving developers a lot of power. Why is that the case? There are multiple reasons. The first one being MongoDB is inherently very easy to get started with and easy to use. Our customers tell us that the first 10 minutes of using MongoDB is a breeze and instantly gets them hooked into the modern way of developing applications using MongoDB. And the reason why it's easy to use is because as a developer, you don't need to worry about setting up tables and relationship between tables before you even start building your application. You start an instance of MongoDB, whether it via Atlas or locally, get a connection string, and connect your app code directly to MongoDB, and it just works after that. Whatever objects you have in your app code will directly translate into objects in MongoDB, and that becomes your data. So it's super easy to start and super intuitive to understand. If you understand object-oriented language and how data structures work there, MongoDB, and if you are familiar with JSON, that is MongoDB's data structure. The second reason is it's highly flexible, which means as you are developing an application, you start with MongoDB and you have a simple data model, and then you can, over time as your app develops, add more complexity to your data model. And because we are flexible, like it's very easy to add that complexity, add more nuances, add more richness into your data without going through very complicated, costly, or complex schema migrations, which happens in the world of relational databases. And lastly, MongoDB performs very well at scale due to some inherent mechanisms built into the MongoDB, such as seamless, like horizontal scaling, which means as your application becomes very, very popular, you don't have to worry about scaling too much. MongoDB can perform really well at scale for you. So it's the reason why giving such power to users is important is in the modern world, applications are not static. They are evolving over time. They're evolving, very quickly. Facebook, for example, started with having just a directory for Harvard students, as you know, in 2005. And then over a few short years, they started adding functionalities such as photo sharing, newsfeed, APIs, so that other companies can build apps on top of Facebook, such as games, and users can play those games within the Facebook environment, etc. And to this day, the app continues to evolve at a very, very rapid pace for a company their size. And what this means is the underlying data model for the application also needs to change very, very quickly as your app develops. So let's stick with the social media example where you have an application. The 1.0 version of the application is just a directory. Then you add other features to the application, such as ability to upload photos and share photos, or add other information about yourself. And then you evolve the application again and add other features and functionalities, and you keep on going. So what's interesting is the underlying data which is supporting this application obviously also needs to evolve very quickly. So for your first version of application, it's the simple directory. So you have a very simple data model with name, age, and zip code. In the second version, you have the same things, but you added extra functionality for users to tell us what their favorite songs are. In this case, John likes big data and hold on. And you could represent that as an array, for example, in MongoDB. In the third version, you want to let John express what his job is in the social networking app, and you add a jobs object in your data model. And the jobs object itself is another JSON document which can be embedded with position and employer details, etc. So as you can see, like in this very simple example, your data model is changing as you're adding new features and functionalities within your application. And the cool thing with MongoDB is because it's very flexible and you can add other richness to your core data model, and it makes it very easy to transition between these different data models, you are able to evolve extremely quickly throughout the application lifecycle. But obviously, if you think about it, the lot of all this flexibility and all this power we give to our users also can increase responsibility, which users have to shoulder in order to make sure that the app that they had built works properly. So what does that actually mean? So there are a couple of things. As an app developer, you're not optimizing for performance in the beginning. You're optimizing for getting your application out the door and building relatively simple data models which are easy to understand and easy to build upon. So, and you're okay with that because you know that the data model, you don't have to factor in for additional complexity, which the app might evolve into at some point. You just start with something simple and you evolve that over time. And that's great because it allows you to move very quickly. But the problem is the decisions that you make in the beginning or decisions that you make today might work for you now, but might not be the best best data model for the future, where your application is either very different or the usage pattern of your application is very different. So in other words, like what works today might not work well in the future. The second thing is you could make a decision which is less than optimal. Like you could be using patterns in how you design your MongoDB schema that may appear good, but there could be potential performance problems being hidden by those patterns. And one of the problems about not thinking too much about schema is the decisions you make in how you design your data model can potentially hide deep performance issues that only manifest itself once you get at a certain scale. And I'm going to talk about what some of that could be. And lastly, because of those above two reasons, that what decisions you made now might not work well in the future, and if you have a bad data model or a suboptimal data model, it can hide performance issues now, which manifests itself in the future, means in the future, you might get to a state where a scaled app with hundreds of thousands of users or millions of users, you might be paying more for performance than another app which has similar traffic but was designed more optimally. So in the end, while you might not face any of these issues now as you're starting to build an application, if you make mistakes in your data model or you utilize suboptimal patterns, over time, this can cause lots of problems for you. So it's good to keep that in perspective. So while we are telling you that we're giving you a lot of power, which is amazing, you might be asking us that, oh, are you increasing responsibility on me as well? Now I have to think about what data model makes sense now versus the future, and how do I change the data model or evolve the data model to keep into account good performance? That's a lot of responsibility. And I don't know about you, but in general, I personally, not a huge fan of responsibility. So how do you balance that? How do we as a company which is offering you a valuable service balance giving you great power of an easy to understand, fast, flexible data model to something which you don't need a lot of responsibility and thought to manage. And hence, as you can understand what I'm alluding to, our users are always asking us, is there something inefficient about my current schema that I'm not aware of? And that could be for a multiple reason. It could be because they're not aware of it because you're not an expert on MongoDB. And obviously, while we want our users to be proficient at using MongoDB, we don't expect all of our users to have the 10 years of MongoDB experience and knowledge and insight that some of our rockstar consulting engineers, for example, have. They ask us, if something is inefficient about my current schema, what can I change to make it more efficient? What is that exact thing that I need to do? They ask us, what is the right time to change it? Should I do it now? Should I do it later? Should I do it at a particular scale? Should I do when things change? Those are very common questions users ask. A lot of users work in smaller organization or in smaller teams where they're only getting started with using MongoDB. They just don't have the time to understand the in-depths of how the MongoDB internal works, so they just want us to tell them. And then we have a lot of users who work in very large organization where they could be part of a DBA team, and they service potentially hundreds of teams building applications on MongoDB. And some of these teams might not know how to data model properly on MongoDB. and they want tools to help them explain to their developers what to do, like how to create more performant data models, or how to think about different performance issues which might come up. And these are all very legitimate questions which any user using MongoDB at scale is facing or thinks about. And we've spent a significant amount of time in the organization to think through how we can solve these problems. And today, we have a lot of tools to help users do that. We have great tutorials. We have great materials online, and we have really awesome university courses. We have blog posts. We have blog series. I think someone from the company wrote a book about it. And we have consulting engineers who are both really expensive ones and not so expensive ones, who can come in and help you grapple or grok these data modeling issues. Well, all that is great. That wasn't enough for us. We wanted to figure out what else can we do to make it even simpler. What else can we do to make it even more obvious to users, what they need to do. How do we make the whole aspect of modeling data as simple as the first 10 minutes of using MongoDB? So this is where we decided, okay, what if we can build a tool which helps users do that? What if we can build a tool which can help guide you proactively to a better schema without that much effort on your end, and at scale, that we can scale to all our customers, independent of whether the customer has ability to pay or time to ingest all our materials. So without further ado, I would like to introduce schema suggestions in Atlas. I completely understand those are fairly long-ass introduction. And what schema suggestions in Atlas would do is it will automatically analyze your collections. By analyzing your collections, it would identify common anti-patterns which users are implementing. And then it would give you a series of steps you can take to improve your schemas based on how to fix those particular anti-patterns. And this is available now in Atlas, and you feel free to go and try it out. So let's talk through how you use this, how you use the tool. So I'm going to show you a series of screenshots first. And then I'm going to dive into Atlas for a few minutes and show you how the tool works. So how do you use it? The tool schema suggestions can be found on Performance Advisor under the Schema Anti-Pattern tab, as you can see from the red diagram, red arrows. Performance Advisor, as you know, is a tool in Atlas. One of the things it does is it suggests indexes. Now it will also be suggesting schema anti-patterns. If there's a suggestion, I would show up. And for example, the suggestion in this particular case is avoid using unbounded arrays in documents. The definition of an unbounded array is an array which has in theory, a very large number of entries that could keep on increasing over time. So we give you the suggestion that this is what we suggest you do. You try to avoid using unbounded arrays in documents. We tell you which collection it affects. In this case, it affects schema suggestions demo.demo1. That's the particular namespace. We tell you what was the reason why we flagged this particular issue. In this case, it's arrays over 10,000 entries detected in the collections that we scanned, which is demo 1. And then we tell you what's the reason why we have this, why you should be taking stock of this particular suggestion, and what are the things you can do to fix it. So today, when you click Learn how to fix this, it takes you to documentation which we wrote, customized for this particular suggestion that can outline a series of steps you need to take. So let me quickly go over to Atlas. and show you the tool. All right, so I'm in Atlas Performance Advisor. As you can see, I'm under Schema Anti-Pattern, and it tells me to avoid using unbounded arrays in documents, the example that I just walked you through. And there are two call to actions for you. One is you can learn how to fix this issue. Clicking on it will take you directly to the documentation page that we custom wrote for this particular issue, and would give you examples of when this issue would come, how to discover it yourself if you want to, and what are the series of steps you can take to make it better. And if you want, you can also chat with an expert about this particular problem, and they can give you some more tailored advice. So this particular tool exists in Performance Advisor, but this also exists in another place in Atlas called Collections. So Collections is our tool where you can go and query data in the GUI, or build indexes, or build aggregation pipeline, or build search indexes. So under Collections, you can also see Schema Anti-Patterns, and this is the same anti-pattern that we have outlined before in Performance Advisor. So one obvious question you might ask is, what's the reason why the tool is available in two places? It's really because there are two different use cases. In Performance Advisor, the use case of schema suggestion is it allows Performance Advisor would automatically scan all your collections to figure out which are the most important collections that require help, and for those collections, it will highlight a list of anti-pattern. So it's really for applications which have already scaled out, and you're trying to figure out what are the areas you should be prioritizing. And then Data Explorer is really for developers who are only beginning to build applications. And you can select a collection which might not be very active, so it might not show up in the top 20 most active collections. And then for that particular collection, see the list of anti-patterns. So it's a very different way of using it. This is more for making sure as you're developing an application, you're doing things the right way. And the other one is making sure that once your application is at scale, what are the most important areas for you to focus on. So going back to the deck, as I explained a couple of minutes before, we have it in two places. We have it in Performance Advisor, we have it in the Collections view. Performance Advisor is about reactive indexing, reactive suggestions, which means once you have your application deployed in production, it's performing at scale, what are the areas that we should be focusing on? And the Collections is more proactive, which is you're building an application, you have a new collection, and you can use it to understand schema issues. So what are the suggestions given today? There are a variety of different types of suggestions. I bucketed them under global, index, and queries and data models. So global would be more global level schema suggestions. Index and queries are suggestions pertaining to indexes and your query patterns, and data models are suggestions pertaining to your schema. So for global suggestions, we call out when you're using namespaces inefficiently. For indexes and queries, we call out when your indexing strategy is inefficient, or when you're using case-insensitive regex queries, which surprisingly happens a lot. And for data models, we call out things such as when you're improperly using arrays, or you're improperly using relational patterns within the context of MongoDB, or when you have very large documents. So these are the V1. This is a V1 feature. So these are V1 anti-patterns and suggestions we give out. The goal is obviously to add more suggestions over time, but you should go and check out whether for your current application any of these suggestions apply. Cool. So I want to quickly talk about how this works underneath the hood, because we're all geeks and we love understanding of how complex and cool technology works. And Again, this is not an engineering deep dive. This is more of a system architectural view of how the product works. So at a high level, like the engine has a bunch of different components. And obviously it's not that simple, but the components are: it analyzes your activity, it analyzes the shapes of collections, and then based on the shapes, it identifies the suggestions to make. So pretty straightforward. It first analyzes which collections are the most important, then it analyzes the shape of a particular collection, and then based on the analysis, again, it tells you what are the schema suggestions that is worth highlighting. So how does it analyze the activity? There are a bunch of things we do. We try to estimate which collections are the most important collections for you. Then we rank them based on how many reads and writes per second that we're seeing on these collections. And then based on this ranking, we come up with a list of collections which are the most important ones for you to take heed of, and if there are suggestions in those collections, those are the things you should be focusing on in the beginning. And we also look at the type of operations happening on those collections to understand the composition. So for example, we would look for what percentage of those operations are aggregation queries, and what percent of those operations are using lookups, for example, in aggregation queries, etc. So the second step is, once we have the list of top collections and the composition of queries happening on those collections, the next thing we do is we try to analyze the collection shape. Obviously, customer data is always encrypted in Atlas. We can never see it. The only thing we can see are shapes. So what does shapes mean? Let's go into that in a sec. The first thing we do is, we sample a statistically significant percentage of documents in a collection. Obviously, we can't go through all the documents in a collection to understand shape. We would take n percentage of those collections up to a certain value, in the hope that alone would be statistically significant for us to understand characteristics of the entire collection. And for each sample in the collection, we calculate statistics to describe the shape. There's a lot of things we calculate, and if you have questions after the presentation is done, I'm happy to answer them. But a few examples of statistics that we collect from collections are things such as what percentage of documents have an array in them, what percentage of documents have an array with a size greater than X, or what is the average size of those documents per collection, what is the distribution of average size of those documents in a collection based on the sample. So in this particular example, you see, this particular document has an array. It has a subdocument called awards, multiple subdocuments. It has around 10 top-level fields, etc. So these are the type of statistics that we would be collecting by analyzing a sample from each collection. Now, once we have those statistics in place, we have an engine which can look through the statistics and identify when is it worth calling out a schema suggestion. In other words, statistics are used to identify that there are improvements that can be made on the schema. If we're confident that this is worth calling out, we would highlight it to our users. And once we highlight that to our users, we give you suggestions. And like I mentioned, the suggestions on what to do. And these suggestions can be found in docs.mongodb.com or community.mongodb.com on how to take heed of these advice and implement those particular schema suggestions. Again, going back to the type of suggestions we're making, we call out when you have too many namespaces, which a fair number of users have because they have a multi-tenant architecture. We call out when you have too many indexes, which can impact your write performance. We call out when you have arrays with a large number of items, which can cause index builds to take a very long time and take up a lot of space and writes to be slower, for example. And we also call out when you're using a relational pattern in MongoDB when you shouldn't be, for example. Like a manifestation of this is you're using a large percentage of your queries on collection foo are lookup queries. So what's next for us? Like I said, this tool has been out for a couple of weeks. We are beginning to get some early feedback from our users on how useful they find it and what they want to do next, what they want us to do next. And I would highly encourage you guys to go in and take it for a spin and tell us that as well. Obviously, we want to add more types of schema suggestions beyond the preliminary list that we have. We want to create alerts when a suggestion is found. In other words, run this in the background for you on some cadence and then tell you that, hey, we found a bunch of suggestions, as opposed to you having to proactively check Performance Advisor. We want to create more personalized analysis of why suggestions are important, with potentially some estimates of what the benefit you would get if you heed the particular suggestion. And in 2021, next year, that is, we want to figure out a way to map a suggestion to a particular pattern to use. So for example, if you're seeing a particular way you're using MongoDB, we can tell you that, hey, this is another template of a different way I can use MongoDB, the data model, for example, which would be, super, super interesting. Anyway, so before I leave, there are a couple of other very helpful talks around this topic, which you should definitely try to join. A bunch of my colleagues are going to be talking about different ways of thinking about schema design on MongoDB. There's both advanced and beginner courses. There's going to be some more specific courses about, or specific talks about how to, whether some patterns are important or not, such as whether the attribute pattern is obsolete or whether it can still be used, etc. So I encourage you guys to go and give it a spin. Thank you all for listening. I hope this was informative. I really hope you guys, whether everyone goes and tries out this particular tool on Atlas, and feel free to send me feedback at res@mongodb.com. Thank you.